Anusha Bhattacharya. The name of my project is Adsorption of Nitrophenols using N-doped carbonaceous material. Water is a vital part of our lives. In fact, 70% of our body consists of water. Now, just to throw some statistics out there, 1 out of 9 people around the world does not have access to safe drinking water. That is nearly 1 billion people in our world. And then to throw some more statistics out there, nearly 850,000 people in our world dies because of water contamination each year. And then on top of that, countries like America, nearly 63 million people get exposed to contaminated water. Now, the main sources of water contamination is 3 things: sewer systems, industrial systems, and the agricultural system. The agricultural system feeds the 7.5 billion people around the world. So that sort of shows how big that system is. But that also means the production of hazardous chemicals such as insecticides, pesticides, and herbicides. Now, hazardous chemicals such as insecticides, pesticides, and herbicides contains a high priority pollutant deemed by the EPA called nitrophenols. So just to show how big an issue nitrophenols is, a small dose of nitrophenols can cause eye, nose, and throat irritation, while a large dose can cause severe kidney and liver damage. Now, in my project, I created an inexpensive and environmentally friendly adsorbent, which basically is able to use a method called adsorption to remove nitrophenols from water effectively. The materials that I used for my adsorbent was cellulose, dopamine, and titanium oxide. Now, after making my adsorbent, I did a simple morphology study using an SEM and TEM image to see how porous my material was. After seeing it was porous, I did a simple UV spectrum in order to see whether or not my adsorbent is working, which it was. Now, after finding all that out, I wanted to see how my adsorbent would work under real-life situations, so I tested different variables such as varying the pH, varying the adsorbent dose, varying the initial concentration of nitrophenols, and then testing to see how my adsorbent was able to remove different types of nitrophenols. I tried the 3 main types of nitrophenols. After doing that, I was able to find out that my adsorbent was able to remove 80% of the nitrophenols from water under the best experimental conditions. Now, after doing that, I used an equation called the Langmuir isotherm equation, which basically allowed me to calculate something called the adsorption capacity. The adsorption capacity basically allows me to see how many milligrams of nitrophenols is able to be removed per gram of my material, and that value was 52.91. Now, this value compared to other adsorbents already created is pretty high, but still not the highest. But the reason my adsorbent stands out is because it's inexpensive, environmentally friendly, and on top of that, can be reused, which is a huge cost benefit. After doing a cost analysis of my material, 1 gram of my material basically costs less than $1, but can be able to filter millions of liters of water at a time. Thank you.